Okay, in this first section we got to draw these pictures. So I need to draw a angle bisector, one of them, just a single one. We don't have to draw all three of them in there. So let's see about here. I don't care how far you go, but we have to mark and show that it was an angle bisector. So I do that by showing that the two angles that are created are congruent to one another. Number two, a mid-segment. Well, the mid-segment connects two midpoints. So I have to draw the midpoint of two sides. So let's say this is the midpoint. To mark that it's the midpoint, I have to say the two halves are congruent. The midpoint of this segment would be roughly here. Let me go up a little bit. So I can show that this segment is congruent to this segment. And then you just connect those two. So there's that mid-segment. That's all we have to mark, is just show that those were two midpoints. I don't have to talk about how this length compares to this length right now. I could, but this is sufficient. A perpendicular bisector does two things. It's perpendicular and it bisects. So I need to bisect a side. So let's say I'm going to bisect the side on the bottom. So I have to mark its midpoint by showing that the two halves are congruent. And then I need to be perpendicular. We show that it's perpendicular by giving the right angle. So here's an example of a perpendicular bisector. This next section, matching. The blank intersected the circum center. Well, that was the perpendicular bisector. We talked about that on Monday. E. Number 5, what intersects to make the incenter? Well, that was what we talked about on, E was what we talked about on Friday. Perpendicular bisectors. Angle bisector is what we talked about on Monday, so B. The blank is equidistant from the sides. That was Monday. That was the incenter, which was created by the angle bisectors. Number 7, the blank is equidistant from the vertices. I spelled vertices wrong there. Should take that out that I. But it's equidistant from them. That's what we talked about on Monday. That was the circumcenter, which was created by the perpendicular bisectors. Number 8, what is parallel to the non-adjacent side? That would be going back clear back to Thursday, which was the mid-segment, so D. Okay, fill in the blank with sometimes, always, or never. So the circumcenter is blank outside the triangle. Well, a circumcenter can be inside the triangle, on the triangle, or outside. So because it can be any of those, this is a sometimes. The mid-segment is twice as long as the non-adjacent side. Let's take a look at the mid-segment we drew up here. It looks to me like the mid-segment is shorter than the opposite side. In fact, we know it's half as long. So it is never twice as long. It's always half as long. So I would say never to this one. And number 11, the incenter, that's what we talked about on Monday. It is always inside the triangle. All right, let's take a look at this picture and make the markings we know to be true before I ever worry about 12 and 13. So it tells us that CD is a perpendicular bisector. So it's perpendicular. And D is the midpoint. It bisects AB, so A to D and D to B are both congruent. And then I see that C is on the perpendicular bisector. And we said that a point on the perpendicular bisector is equidistant from the two endpoints. So the distance from C to A and C to B are both congruent. So I can mark them as such. So question number 12, so technically they shouldn't have these segment lines above them. We're talking about distance. If A to B is a total of 10, that's all the way across, what is A to D? Well, that would just be half of it, so that would be 5. Number 13, if A to C were 15, what is C to B? Well, that would have to also be 15. Now let's go to the back page. We have an angle bisector, so I'm going to mark that as such. This angle is congruent to that angle because it was bisected. D is on the angle bisector, and we know that any point on the angle bisector has to be equidistant to the two sides. Distances are represented with right angles, so they already have right angles. So yes, I know D to A and D to C are congruent to one another. So number 14, so again I can take off the segment lines. If AD is 7, what is DC? Well, that would also have to be 7. Number 15, if ABD, this angle up here is 35 degrees, well, it's bisected, so this would be 35 degrees. Also right there, they want us to find A to B to C. That's the whole thing. So we have 35 plus 35, which is 70 degrees. next few problems should look similar because we've had these on worksheets. So this next section, we have perpendicular bisector. We know perpendicular bisectors are equidistant from the vertices. So O to M, O to P, and O to N are all congruent. They're all the same distance. We see one of them is 26.8, so all of them are 26.8. So question number 16 was M to O. Well, that would be 26.8. Number 17, from P to R. Oh, well, if this is a perpendicular bisector, O to R, it does bisect the side, cuts in half. So if this is 26, this has to be 26 over here as well. That's the one they were asking for, so just 26. M to N, well, from M to Q is 20. Q to N would have to be another 20, so it's a total of 40. Number 19, from S to P, well, M to S is 22, so S to P would be 22 also. And number 20, O to P, oh, we already marked that. That was one of those distances, or the distance from the circumcenter to a vertex. They're all the same. They're all 26.8. Now we talk about incenter. This is from Monday. Well, we said the incenter is equidistant to the sides, so the three distances to the sides represented by right angles are congruent. So T to W, T to U, and T to S, those are all the same. Each of them then being 15, since we know one of them is 15. They're asking for S to T. Oh, that was one of those distances. We already found it, 15. Number 22, it's an incenter again. So P is the same distance to Q, to U, and to V, but we don't know any of them. We do have a 12 and a 13. We have a right triangle. We know this has to be x because it's the same as that. So I can do Pythagorean theorem with x, 12, and 13. So x squared plus 12 squared is equal to 13 squared. So x squared plus 144 is equal to 169. Subtract 144 from both sides, I get 25 square root, and we see that x has to be 5. Now we jump down to the segments, which we talked about Thursday last week. So AC, okay, that's this right here. What's it parallel to? Well, it's parallel to a mid-segment. The only one that would never intersect it, that would have to be DE. They have to have the same slope. So DE or ED. Now AB, okay, AB would be over here. What's it parallel to? Well, it can never intersect it, so that would have to be over here at FE or EF. Okay, if AB equals 12, let's take a look at that. AB is this side over here. If it's 12, we know that D has to be midpoint, so we can cut 12 in half to 6 and 6. And then EF is the one parallel to it. It has to be half the length, so it's 6 also. So all three of those segments are 6. They want to know what EF, which we just found, is 6. Okay, now BE. Okay, for B to E, they said that's 7. Well, E is the midpoint, so E to C would also be 7. And the mid segment that's parallel to it from D to F would have to be 7 also. That's what they just asked for, DF. That would have to be 7. D to E is 5, so that's a mid segment. So the side opposite, A to C, would have to be double that, which is 10, but each half would then be 5. So I have all of those filled in. AC was the whole thing, which was 10. So now I can answer number 25. They want to know the perimeter of triangle DEF, using based off of all those information we just found. D to E to F and back around. So 5 plus 6 is 11, plus 7 is 18.